Welcome to Utkarsh Minds Python for Statistics and Data Science. In today's video, we will see the effect size for the Wilcoxon test. Wilcoxon is a test for ordinal data and single variable. Since I am going to implement in Python, I will launch my Colab notebook, colab.research.google.com. Click on new notebook. That will launch a new Python notebook for me, in which I will write my program for the Wilcoxon test. So in this notebook I am writing effect size, because this will be for the Wilcoxon test. I will click on connect and I will have to upload my data set here using this folder icon, and once it is uploaded I will select the GSS file, because that is what contains the data of the student survey. Once it is uploaded, I will write the standard steps. So for the Wilcoxon test, I will not implement the Wilcoxon test, but only the effect size. For implementing the effect size, I am writing from scipy.stats import norm. Just to give a brief recap of the use of this effect size. Remember, we had in the previous video calculated the p-value. If the p-value was less than 0.05, which was the case, we rejected the null hypothesis and we said that the median of the population is different from the x, which is our hypothetical median. It is different, but how different, that we will calculate with the use of effect size. That means, is it negligible difference, small, medium, or large difference? How much is the difference? So the effect size is known as Rosenthal coefficient or the Rosenthal correlation coefficient. To calculate this, we will need the p-value. So I am using the p-value from the previous video, which was 5.58 e raised to minus 96. How I got this? You can refer to my previous video on the Wilcoxon test. Next is to calculate the z value from this p-value, which we will get by p-value divided by 2. Then what is the sample size? So n is the sample size. This also we get from the previous video, and this sample size is equal to, let us say, 942. But you can calculate the sample size from the previous data by using this formula, ordinal data. Remember that ordinal data is the variable that stores your ordinal data, and n is the length of that. Next, to calculate the Rosenthal correlation coefficient, I will give it the name R rose, is simply the absolute value of z divided by square root of n. That's it. Now that we have got the correlation coefficient, we have to find out how to interpret this. So if the correlation coefficient is less than 0.2, then we will say the difference is very small. Else if, so I will just copy this part, if it is 0.4, then it is, I will say that it is small. If it is 0.6, then it is medium. Further, if you say that it is 0.8 or larger than 0.8, if it is 0.8, then it is strong, and if it is greater than 0.8, then it is very strong. Depending on how much it is, we can run this and see if there are any errors, and we are getting that the difference is a strong difference. In short, we will write one sample Wilcoxon test indicates, or the test can also be named as Wilcoxon signed rank test, indicates that the median of the population is different from X, which is the hypothetical median. Here I will have to indicate my p value, which was less than 0.001. X will be, let us say, I think we had assumed in the previous video X to be 2.5, and the Rosenthal correlation coefficient indicates the difference is strong. Okay, so this is how we write the conclusion of the experiment. Here I want to draw to your attention that we have utilized a sample. So this is just a sample, but the conclusion is for the population, which is what the purpose of data science is, to make a prediction about the population based on the sample, experiments on the sample. So we conducted one experiment and we proved that through this experiment our median of the population is different, and the difference is a large or a strong difference. So I will just call it a large difference instead of strong difference. It doesn't matter the wording, you can have it different, but make sure you write which test you have used, what was the hypothetical median, what is the p value, and which is the effect size and the interpretation. So that's it about Rosenthal and effect size. See you in the next video. Thank you for watching.